Okay, let us start. Now, uh, there are some properties of bounds of a sequence. So let me first put this. Okay. Now, if consider K1, okay, is a lower bound, okay, and K2 is an upper bound, okay,
Hmm.
of the sequence, of the sequence, okay, that is sequence is represented as like this, okay, then K1 is less than or equal to 8, okay. Now,
Sir, can you tell me what is bound? Actually, what is bound? What is lower bound and upper bound?
a lower bound is the uh, one which is the least, okay, like
Okay.
we have the least value, and suppose if I draw a line, so okay, so this is considered to be a lower bound, and this to be the upper bound, okay.
Okay. Hmm.
Yeah, boundaries, like bound.
Okay. Okay.
Yeah, so let us move on further, okay. So let's see, and please remember, infimum, okay, infimum, what is infimum?
Yes, sir.
Infimum is the greatest lower bound, okay. It is also called greatest lower bound, okay.
It is
So
also called the.
greatest lower bound
Okay. The greatest. Okay. Hmm. Okay.
of a sequence, of a
Hmm.
sequence, uh, if it exists and is in, if it exists, okay, if it exists, uh, it is unique, okay. Okay, we'll try to solve a few examples, okay, based on this bounds, okay. If I consider, let Sn be a sequence, be defined, okay, by Sn. Now, this we have learned yesterday, that k is some constant, okay,
Yes.
which
Yes.
belongs to some r, okay,
Hmm.
and it is a real, okay, for all n belongs to r, uh, n belongs to z plus, okay, n belongs to z plus, where z plus is a positive integers, okay. Let us see that
Okay.
now. uh, Now if I put n is equal to 1, I get s1, that is k again, constant, right? S2
Yes.
again k, right? S3 is again k, and so on. Now we have already discussed what is the range of this, right? So range will be of the sequence is k itself, correct?
Yes.
Yeah, and uh, it is finite set.
Yes. Yes.
Yeah. So for n is equal to 1, or n is equal to 2, n is equal to 3, you get k. So the range is now. Uh, Therefore, we found the range of this. Okay, so range also it is a finite set, and it is bounded. Bounded. Therefore, the range of the sequence Sn is bounded. Okay, and hence uh, the sequence is bounded. So range is bounded and the sequence is bounded. Now, since k is finite, okay, and it's constant, and therefore we can say that the greatest lower bound, okay, or the infimum is equal to k, as well as the lower bound is k. Okay, so we got the greatest lower bound as well as the lower bound, which is k. Throughout, there is no maximum, no minimum, constant throughout. Okay.
Okay, okay.
This serves one problem. Let us see another problem. Now, if I consider a sequence, okay, which is defined. These are the sequence which is defined between uh, certain definitions. Okay? So we are trying to see and try to test whether this is uh, bounded and does it have range and so on. Okay.
Okay.
So this is how we test. Now this is again, what do we understand? This is a sequence. It is defined over this, and for n, which is the positive entity, the sort is given. Let us see. Now the process is same. Put n is equal to 1. Okay. So you get S1 would be 0. Correct.
Right.
If you put n is equal to 2, you get S2. Now this will be 2. Okay, because it is 1 plus minus 1 whole square. So 1 plus 1 is 2. Yes. If you put n is equal to 3, now you get 0 again. Now put n is equal to 4, you get S4 as 2 again. Now you observe this, you are getting 0, 2, again 0, and 2 again. Now if you keep on doing for n values, you get the same values, which is 0, 2, 0, 2, and so on. So we can stop this, and
Yes.
yeah, therefore let us write the range of this. So range would be
0,
0,
2,
0 to 2.
comma
Yes,
2.
yes, 0, comma 2. And is it a finite? Yes, it is finite. It is a finite set. Okay, this serves our purpose. Now we found the range. Now is it bounded? Yes, it is bounded. So the sequence Sn is bounded. Yeah. Now bounded. Now we have also to show that the infimum, okay, the greatest lower bound, which is equal to 0, okay, and the least upper bound, okay, and that is 2. Upper bound is 2. Okay, so we will see one more example. Okay,
Okay, yes, sir.
yeah. Now let's see this is bounded. sequence Sn be defined by Sn is equal to 1 by n. Now this is for all n belongs to Z plus. Okay. Now for all n. Okay. Let us see that. Now we have been given n Z plus positive. So 1 by n will be or 0 is less than 1 by n, or 1 by n is greater than 0, and 1 by n is less than or equal to 1, because fractions, right? So 1 by 2, 1 by if you take 1 by 2, it is 0.5, and if you take 1 by 3, okay, you can 0.33 something, right, and so on. So which is less than or equal to 1. For n is equal to 1, you get equal to 1. Okay. And you can see that it lies between. So therefore, you can say that 0 less than n and less than or equal to 1. Combining this. Okay. So this serves the purpose. So 0 and 1. Okay. It is not equal to 0, okay, because it is less. It is equal to 1 or less than 1. Okay. So for all n belongs to Z plus. Now, what we are going to, let us put that back again, the sequence Sn, okay, which is less than or equal to 1 for all n belongs to Z. Now, yes. Now, is it bounded? Yes, it is bounded. Therefore, Sn is bounded. And what is greatest lower bound? Which is 0, and is 1. Is
Okay.
okay. Yes. Clear?
Yes.
Yeah. We'll see one more example of this.
Okay.
Now, let us consider another sequence Sn. Okay, be defined by Sn equal to minus 1 to the power of n. Okay, for all n belongs to Z. S1 equal to 1, S1. So we get that as minus 1. N is equal to 2, S2. We get this as, what is it? What do we get? 1, right?
Yes, sir.
Again, for n is equal to 3, S3, we get minus 1. Okay, and so on. So here it is bounded. Yes, sequence Sn is bounded, and it is finite. Okay, it is finite set. So we have the range which is minus 1 and 1, the range. Okay, and greatest lower bound is minus 1, and the least upper bound is 1.
Yes.
So we'll see some more problems. Now let us see what is the limit of a sequence. Limit of a sequence.
Okay. Okay.
The limit of a sequence. Now, how is this defined? In one shot, we can write as limit as n tends to infinity. Sn is where Sn is the sequence. Let us see the example related to that, so that we can understand what we are talking about. Okay. Yeah. If Sn is k, this belongs to some r, okay, is a constant sequence. Is a constant sequence, then limit, okay, or limit Sn is equal to k. Okay, let us solve this. So since we consider that Sn is k for all n, for all n, this implies that now uh, when the limits are there, uh, when you put uh, uh, when you put on the left hand side, if you take this on the left hand side, so Sn minus k, okay, so this becomes an equation, okay, is equal to 0 for all n. Okay. Now, if limit exists, there exists an epsilon. Epsilon is the least value. Okay, so we denote as like this. So we have Sn. This is mod of this is equal to 0 and it is less than epsilon. Okay. And we can write this as Sn minus k is less than epsilon for all n greater than m. M is again the lesser value of n. Here, like rth term we had. What is rth term? Okay. So for m, okay, which is less than n, if you consider n is the last or the finite value. Now, since now let us apply limits. Okay, so limit limit Sn is, why? Because for all n is equal to 1, n is equal to 2, n is equal to 1, right? N is equal to 1, n is equal to 2, n is equal to 3, and all that, we get Sn as k, right? S1,
Yes.
S2. So that's why when you apply limit as n tends to infinity, so you get as k. So hence we are sure that the limit Sn is equal to this.
Okay.